Thanks for coming out. Welcome to day 2 of Google I/O. I hope you enjoyed the great keynote on Chrome. And thanks for coming to this session. Today we're talking about using GWT and Eclipse to build great mobile web apps. My name is Chris Ramsdale. I'm the product manager for GWT and the Google plugin for Eclipse. So let's get right down to it. Let's talk about why we're here. Make sure you're actually in the right room. I'm assuming so. By a show of hands, how many people actually have a GWT application that they've built or that is in production today? All right, great. So chances are there's plenty of people that are building web apps in the audience today, and as many developers are, you're interested in doing something in mobile. So actually, we'll do that too. So show of hands, how many people are interested in doing something in mobile or are doing something in mobile right now? Great, fantastic. So as developers, we like to create efficient applications, right? Ones that run fast. And also as developers, we like to be efficient ourselves. So chances are you started with GWT, you have a web app that you've built, you're happy with it, maybe you have several of them. You have a code base, you have several thousand, tens of thousands, a million lines of code. Wouldn't you love to reuse some of that code when you go to mobile? And also, wouldn't you like to get around some of the friction of getting to mobile in the first place? So let's talk about that. So some of the friction or some of the problems associated with going from, say, a desktop web client to doing a mobile web app are these. Mobile typically has smaller screens, right? And not to mention, not only are they smaller, but they actually are different. So you have tablets and you have phones, and you have TVs, now you have Android running on workout machines, so who knows where it's going. Someday you'll be writing an application running your toaster. They have smaller screens and they're different. You can break it down even further that while they have different, smaller screens, they also have different orientations. You see this most predominantly with tablets. If you take a look at Gmail today, Gmail in landscape mode looks different than Gmail in portrait mode. They typically have slower processors. While they've been on the rise, tablets and phones still lag behind laptops and desktops. And then finally, the one that concerns me the most is that they can be disconnected. In fact, you expect them to be disconnected. They are portable devices. I need to take them wherever I go. I expect to be able to use them wherever I go, whether I'm in a subway station, a subway tunnel, in the middle of Kansas, on the flight I took to Minneapolis to get here where I had no Wi-Fi. I expect to be able to use my applications. And typically, that's easy to do with installable mobile apps. You don't see it as much in mobile web apps, so we're going to talk about how to get past that. So those are the problems. So I wouldn't just leave you with a bunch of problems while you came to this I/O session. I should give you some solutions too, right? That's the whole idea. We're going to learn. So today, as indicated by the title, we're going to talk about how to use GWT and Google plugins for Eclipse to build great mobile web apps for iPhones and Android devices. And specifically, we're going to focus on how to build great UIs for any form factor. Then we're going to talk about how to optimize the user experience. We're going to talk about how to make it snappy, make it fast, right? Because after all, installable web apps, the one leg up they have on you if you're developing a mobile web app is that they're really fast. They happen to run a little bit closer to the metal than when building a mobile web app. But we can get around that. Then finally, we're going to talk about working without a connection, how you would do that. So to drive us through this session, we have a sample app, and it's available as part of the GWT 2.4 beta SDK that we announced yesterday. And specifically, it's a standard application that's web-based. It's a web-based task management application. We have UIs for Android, iPhone, and iPad, and desktop browsers. We show you how to do orientation change handling. We have offline support. And we're going to run through some of the key pieces of that application in this presentation. And I'll keep bumping from code to actually running on the device, and we'll show up pulling all together at the end. So let's jump right in, talking about building great UIs for any form factor. So if you're going to have all of these devices that you're going to support, right, and you're going to have to write different UIs for them, right, and it's really not that much code, and we'll get to that in a second, but you're still going to have to write different views, different UIs for them, we should make it as easy as possible. So the nice thing is that with GWT, and these are existing features, but with GWT we have, if you choose to do it by hand, to code it by hand, we have a feature called UI Binder, which makes it very easy to do declarative UIs inside code. So what does that mean to you? That means that writing UIs is no longer orthogonal to what you're used to. So if you came from a web-based background, a la coding in HTML, JavaScript, and CSS, you can use UI Binder and you feel warm and snuggly like you're at home. Then if you choose to not do it by hand, and you're a lover of developer tools, like we are on the GWT team, you can use GWT Designer, which is now part of the Google plugin for Eclipse for doing UIs in a WYSIWYG tool. So taking the UI Binder route, again, the focus here is to how to make it easy to create multiple UIs with very little friction. So here's an example of a UI binder template. I've stripped out some of the code here for demo purposes, but again, it's all available at the end. So we start looking at a UI binder template, and the first thing we see is that, one, it's XML, so it kind of looks like HTML, that's good. And we immediately jump into style. So in this case, I'm highlighting the fact that we have a style for add button. So that's going to be the little plus icon that I'll show you in just a second. Some simple styling. Give it a color, a font size, a background, border, so on and so forth. And that's all wrapped up in that widget. So one, it's easy to see, so you just open up one file and you can actually see your styles along with the declaration of your UI. And then two, those styles are only per that widget, so you get no pollution of the global namespace, which is really nice. So now we got our styling, let's jump into the actual layout of our application. So what I'm walking through here is the main screen of the task application. And again, a few details omitted, but you're going to get the general idea here that we're walking through, and we see first off that we have the header, the title of the application. And the way we're laying all of this out is using a dock layout panel, which is a GWT widget, and that gives you the north, south, east, west region of your application. So in the north, we're going to put the title of the application. So that's this. Then we're going to drop down into the left-hand side, the west side, which is going to be the task list, right? It's the actual list of tasks that you're going to click on. That's this. And then finally, we come in and we give it the content, right? This is the content area, goes in the center, and that's going to be this, right? So that's it. That's how you start constructing this. Now behind this is a bit of Java that's going to run it, right? That's going to actually feed it data and actually populate all the UIs and everything. But when it comes to constructing the UI, that's the bulk of your code right there, to write this. So then let's say, again, you don't want to do it by hand, but instead you're going to do it with tooling. What you can do is you can drop into our GWT designer. So this is the same view, but brought up in GWT designer. And what you can see is that you've got the title, you've got your header, and you've got your add button. And then on the left-hand side, you have a set of widgets. You have all of your panels that you can drop in there. You have buttons, you have lists, you have cells, you have tables, you have labels, all at your disposal to start editing this UI. And then on the right-hand side, you have the properties for each of those widgets. If you want to change the color, if you want to change the name of it, if you want to change the class, the Java class that backs it, you can do that here. So again, after doing this, what you end up with is two different UIs, right? And you've done it in a very, very limited amount of time. So you have your list view for tablet, and you have a list view for phone. Notice they look different. So this is just the beginning. This is just how you start getting going, right? So we're starting out at ground zero, acknowledging that we need to have different UIs for different devices, right, for the best user experience. So great, that's fantastic. I probably haven't told you too much that you don't already know, because you're already writing UIs and using GWT. So let's move on to the more meatier parts. So how do we optimize the user experience? So now that we have these different UIs, how do we pull the right one up for the right device? And it's more than that. It's not only how do we pull them up for the right device, it's once we have pulled up the right UI, how do we handle orientation changes if we're running on a tablet or a phone? In this case, I'm going to demo how to do it on a tablet. And then we're also going to talk about the icing on the cake. So this is if you've gone through this process and you've created different UIs and you have a way of selecting those UIs and serving them up, what you end up with is a design pattern that works very well for code reuse and actually looks a lot like MVP. So we're going to talk about how you can get maximum code reuse when creating desktop, tablet, and phone applications. So let's jump in right here. So talking about how to select the right UI per device, and we're going to use deferred binding to sort them out. Now, if you aren't familiar with GWT, or you haven't kind of dove in a little bit deeper, you might not know exactly what deferred binding is, so we'll do a little recap. So at the heart of GWT is this notion of being able to generate a browser-specific version of your application and then serve that up when that browser selects it, right? So you get the optimal application. It's called deferred binding. And what ends up happening is the browser makes a request, and through some configuration, we end up picking out the best UI for, say, IE or Firefox or Chrome or Safari. Well, lo and behold, that works really, really well for mobile devices as well, right? So you can say, well, I want to serve up an Android phone-specific or an Android tablet-specific version of this application, or an iPhone-specific or an iPad-specific. You can get as fine-grained as you want to. But for the sake of this demo, let's just talk about how we could serve up a phone versus a tablet view, and we'll dig into that. So I mentioned this GWT module config file, and it's really just an app configuration file for your GWT-based application. In this case, I've got cloudtask.gwt.xml. And inside of that file is a whole bunch of properties that are for your application. So it's where you define all your dependencies. It's where you might actually define your entry point. And then another thing you do is you define some of your deferred binding properties. Right? So in this case, what I'm saying is, as a developer, I want a view factory. Right? I want a factory that's going to serve up my views, and that's an interface that I define. And I have different implementations. Right? So for mobile, I have a mobile implementation of that factory. For a tablet, I have a tablet version of that factory. And then what ends up happening is that those are selected for me under the hood, and it's done with deferred binding properties. And so in this case, it says when the form factor is mobile, give me the mobile version of this view factory. Then I can say, give me my list view, and it's actually the list view that's optimized for the mobile phone device. Subsequently, I can do that with tablet too. It says, okay, when a tablet is requesting my application, give me the view factory that's specific to that, that type of device, that form factor. Give me the tablet version of the view factory. So this is great, pretty easy to understand and to digest, but I keep saying when the form factor is when the form factor is. So what actually is going on there? So under the covers, what's happening is, if you've ever written JavaScript, you've seen this, I'm sure. We're simply looking at the user agent and looking for the existence of, say, iPad, in this case. And if we see iPad, we're going to pass back that it's a tablet. If we see that it's an iPhone, we're going to pass back mobile. And then if we see Android, there happens to be a little more complex heuristic for figuring out whether it's a phone or a tablet. But the fact of the matter is as complicated and overly complex as that is, we just hide it behind this set of code, so all you're doing is writing code that looks like this. Look, just when it's a tablet, let me know and give me the right implementation for this interface, and then I'll go make calls on that implementation that I get back. Good, so now we have this model sketched out to where a browser can make a request and we can give back the right view factory for the phone or the tablet. And now I can pull together these views so that when I get back, say, the tablet version of my view factory, I'm going to pull my list view tablet.ui.xml file. That's how I get to that file. That's the path. Same goes for the phone. And so then we can actually see this over here. Can I get both of them on here? Good enough. Gonna have to change my key combination after that. All right. What's up? What's up? Cool. Move him over a little bit. But there you can see it actually happening. So I just showed you that those two devices actually selected the same application. You can see the URL there and kind of there. But I get served up two different UIs. I mean, they look similar because my application is doing similar things, but you actually get different UIs. Oh, these clickers. Okay, so now that we've managed to pull up a tablet-specific version of the UI, how do we go from just that to responding to orientation changes? So when I flip it from, say, portrait mode to landscape mode. And this is actually much easier than you would imagine. So all you have to do is somewhere in your initialization code, you go back and say, okay, window, the window that I'm attaching to, I want to add a resize handler. There's several ways of doing this. This is how we happen to do it in GWT. And you're literally saying, when the window resizes, let me know, right? And inside of there, you're actually keeping state of where you're at. Like, am I portrait or am I not? So if you go and you calculate, well, am I switching from portrait to landscape, which is a very simple method like this, is my client height greater than my width, right? So if my client height is greater than my width, then yes, I've gone into portrait mode. And if the result of that isn't what I've cached, then I've switched from portrait to landscape or vice versa, in which case I do adjust orientation. Now we could jump into the adjust orientation code here, but it's very application specific. But the net is, inside of this code, you'd simply maybe hide a widget, right? So you might, when you go from landscape to portrait, you might hide the left-hand side, you might hide the content, right? And show just the list. And then vice versa, when you go from portrait to landscape, you would show the content and then maybe minimize the width of the list to adjust to the screen real estate. Then we see that happening here, and it's actually quite fast, so I'm pretty impressed with this. Notice that they're the same. All right, so here we have it in landscape mode, and then if I simply turn it, give it a little nudge, there we go. So you can see that we pop right back in there, and we literally, like, the pause was not our app, the pause was the browser. So if I flip it around, come on, browser. Do you now? There you go. So once the browser starts to switch, our application switches quite fast. There's no delay in the application. All right. So now that we've talked about how to create different UIs for different devices, how to select those UIs, let's see some of the benefits that we can get out of this, right? So this goes two ways. If you're starting to go down this path, you're going to end up in probably a mode that looks like MVP. I'm going to describe what that is in a second. Or if you happen to be an MVP developer already, you can take advantage of these practices. But here's a little recap of what MVP is. So it's a design pattern. So it's a model view presenter. That's what the M, the V, and the P stand for. Design pattern. It's very similar to MVC, only you're going to have a little less logic in your view. All of your business logic is going to go to the model and the presenter. You want to keep the views as simple as possible. And what we've been advocating for the past year and a half, almost 2 years, is that this leads to faster test cycles, right? Because basically what you can do is you can run all of your tests and most of your tests as vanilla JRE/JUnit tests versus running in, say, Selenium or using GWT test case to actually run your application in, say, like a headless browser. So this has been what we've been advocating. And this is really good. What I really like is when you can take this pattern and apply it to mobile. Because what ends up happening is, so whether you have a tablet versus a phone, and it could actually be tablet versus phone versus desktop, right? The business logic is the same. If I'm creating a task application, like that's really not going to change that much if I'm talking about one device or the other, right? If I'm doing an email application like Gmail, I'm just still giving you your email. So that business logic stays the same. All that changes are the views, which we've already talked about. So what you end up with is a pattern that's ideal, right? You've already broken up like what my model is, and then I've got my presenters for a bit of my application logic, my business logic, and then you've got these little views over here that change. So it's an ideal design pattern for supporting multiple form factors. And if done right, what you end up with is code, if you were looking at it from a high level, that breaks down like this. And I'm talking about size of code. So you have all your business logic, which is your presenters. The presenters are driving the views. And then you have your model, which is laying your DTOs, your RPC, your caching, your validation. And then that little part over there ends up being your views. Literally ends up being your factories, right? They can give you back your list view for a phone, or your edit view for a phone, or your edit view for a tablet. And then to tie it all back together, that little piece is really just what's changing in this deferred binding property, right? So as you go and you say, okay, now a tablet has hit my application, I'm going to give back the tablet view factory, and that is that little piece down there that you're serving up. So you end up with, and that's the way you get past the original problem, which was that I happen to have a lot of code already, and it's for a web app, and I want to do something on mobile. Boy, it would be nice if I could use that code over again. This is how you do it. And how you go about doing MVP, we won't get into that today. There's plenty of documentation on the GWT code site. The community has been very, very active about doing it. There's, a handful of projects that actually talk about how to do this. And so I'd advocate you go out there and check those out. So now let's talk about how we can make it snappy, how we can make a mobile web app feel more like an installable app. So we look at it, what is the problem that people that are doing mobile web apps, what do they face? Well, the first problem is that HTTP requests on a mobile device are quite expensive, right? Even on 3G, and especially if you get onto an edge connection, a degraded connection, there's a lot of overhead with setting up the HTTP request, making it, waiting for it to come back. You have to get around that. And then you want to minimize startup time. And this goes back to what I was talking about when you say that laptops and tablets have slower processors. What ends up happening is you take a lot of JavaScript, like 500K or a meg, and send it down the wire. It takes the processor has to go through and parse all of that JavaScript, right? Load it up into memory. And what ends up happening is that the parsing ends up taking time, which ends up degrading the user experience, which ends up draining the battery life, draining the battery right on the device because you're constantly parsing JavaScript and spinning that CPU. So there's some solutions to this that are specific to GWT. So if you want to increase responsiveness, what you can do is you can minimize the number of HTTP requests that you're making. Right? You can bundle all of your resources together so that you go and fetch them. So it's one HTTP request to get, like, let's say 20 images or 20 images and 5 CSS files and so on and so forth. You can minimize startup time by using code splitting. So that the code splitting is just basically lazy initialization of JavaScript. So you can say, I have a big app, but when I get to the settings screen, then go fetch the view from my settings screen, but don't get it on the front end because I don't really need it. And then overall, while you can kind of move the fetching of JavaScript around, what you want to do is overall, you want to reduce the amount of JavaScript that you pulled out in the first place, right? And this is where GWT becomes a perfect match for doing mobile web apps because, we're built upon taking Java and compiling it down to highly optimized JavaScript, right? And we'll talk a little bit about some techniques that we use to minimize the overall output. So I've got a demo to prove some of this. I didn't like that at all. There we go. Okay, so this is not part of the sample application that I've been building up, and I wanted to pull it out for the sake of discussion and to make a point here. It's a simple application that's running on App Engine right now, and what it is an application with a title and a button, and when I click on the button, it's going to go fetch and bring up an image dialog. So one could imagine that if you're actually going to apply icons to your tasks, or you want to tag them with something like this is the grocery store list, or this is the lunch with my colleagues, this is how you would pull up that dialog. And to give you an idea, this is really what it does. So I will go through what is going on in the bottom in a second. But as you can see, it simply pulls up, in this case, 16 images. So let's do this. Let's clear this guy out. And what I'm going to do is I'm going to walk through the waterfall of HTTP requests in 3 different fashions. There's the okay, almost subpar way of doing it, where you don't do anything. There's the better, where you start to bundle things. And then there's the best thing you can do, which is bundle it and then code split it. If that doesn't totally make sense, just bear with me here as I walk through each piece, and I'll describe it in more detail. So to make this real, let's go and clear all my cache, right? And if anybody's asking why I'm using Firebug, it just happens to have a better UI for showing off what I'm about to show off. Feel free to use Chrome DevTools, but this really drives the point home. Okay, so I'm completely clean, nothing in my cache, no magic tricks going on, and what I want to do is I want to refresh my app. So I'm going to show you what happens as you go from refresh to button click. All right. So a little bit about what happens when you do a GWT application. So the first thing you see is we fetch the HTML page, and we look through it, and then we go and we see that, oh, we need a style sheet. So we go fetch the style sheet, and then we see that also in that HTML page, we need the actual GWT-specific JavaScript, which can go fetch the right permutation. That's this nocache.js. Note that it's only 2.5K, it's quite small. And then you see this really weird MD5 hash down here, sorry, right there. MD5.cache.html, and that's actually all of the JavaScript for your application bundled up in there. And you can note that this is 19K, so it's not huge. I'm not showing a huge application, but that's where all my app logic is coming down. So that's not too bad. I mean, that's pretty fast. What ends up happening, let's pull this up, and I clear this, and then when I click on the icon, boom, all right. So again, I'm on an Ethernet connection, so this is going to be pretty fast, but let's pay attention to the waterfall graph on the bottom. You see that I go and I fetch every single image one by one by one by one. And it's really not that bad. I mean, it was pretty snappy. You probably saw a little bit of a delay as it kind of got one in and then put it up on the screen. And if you refresh it, they're going to be cached anyway, so it doesn't matter. But this is on a desktop browser, right? And so you see, I go fetch every image, and Firebug does a pretty good job of breaking down what actually happens with each request. So you can see the purple is waiting, right? And then the gray actually is receiving. And then the one on the left-hand side is when you're actually blocked. So I spend quite a bit of time just waiting for the HTTP request. To make matters worse, let's see if I can pull this off, switching around. Yeah, great. So to make matters worse, when you're on a mobile device, so here's the difference between desktop browsers and mobile browsers. The number of concurrent TCP connections is greatly different, right? On modern browsers, you can get 10 plus concurrent connections to the same domain. On Android devices, and this came from our page speed team, great guys, you get 4 concurrent TCP requests. Now that's changing, and it's getting better with Honeycomb. They've upped the number, but when you're still catering towards Froyo and Gingerbread 2.2 and 2.3 devices, this is what you get. So 4 at a time, you're going to start to see that graph that I just showed you over here, looks a lot worse because you see how I've done everything concurrently down here. That gets broken up. So it gets even worse for mobile devices. So how can we make that better? So I alluded to the idea of bundling up all these resources. So we could take these 16 resources here and bundle them up and then just go fetch them at once. So let's see what that looks like. So again, let's clean everything up. No sleight of hand. Clear. Oh, no, come back. Okay. So now I have my snappy application. Okay, so what I've done here is I've bundled all these up, and we'll see the difference. Okay, so I go in and fetch. And the mode of getting the actual files and the files that I fetch are exactly the same. I get my HTML page, I scan through it, I get my style sheet, I go get my nocache.js, and then I get my application, right? But now you can see that the MD5 hash, my actual application, went from 19K to 177K, right? Because it's got all those images. Now to prove that out, if I clear this, before I jump to that, so note that it's 177K, and let's see, the wait time was 400 milliseconds, right? So it's very similar to what the wait time was before. So really what I'm paying for is the receive time over here. Sorry. If you can see it, receive time, 446 milliseconds, because it actually fetched all those images. And to prove that it fetched all those images, look what happens when I hit the select icon button. All I'm picking up, and look at the sizes, they're very small, but all I'm picking up are some artifacts that are used by our own styling, like borders, or clear cache GIF file. But we're talking 433 bytes, 1.5K, nothing that big. And you saw how fast it popped up too, because it already had all those images. It's great. So real quickly, let's look at how we would do that. So to do this, we can enumerate all of the resources in our application, put those into an interface. That interface is something that extends client bundle. Again, for the complete documentation, definitely go check out our dev guides and our Java doc. But what we do is we annotate this and we provide a method so I can call image 0. So I can say resources.image 0, and I will get back the image resource for of my file. And I can do that for all 16 of those images. And then when the GWT compiler runs and the code generators run, we go and fetch all those resources, we package them up into one data file, and then we basically do spriting over those data images. But the problem is, let's see this again. The problem is that now that I've fetched all of my images, I fetched them on the actual app startup. So especially on a mobile device, this is going to be a huge time suck, because I'm going to have to go and when I initially hit the application, there's going to be latency there. So while the rest of my application operates very smoothly, and by the way, imagine this not with 16 images, but with 1,600 images or 160 images, something more like a real app. And all of a sudden, it's going to take 10 seconds for your application to load for your user, or 20 seconds for the application to load. And that's just a real poor user experience when they start up. Not to mention, you might not even use any of those images. I may never actually use your application and clicked on the button that says, I want to add an icon to my task. I just don't care. So how can we make that better? What we can do is we can code split it. And again, what I'm going to do is I'm going to say, all right, I want to bundle the images, but only fetch them when the user actually clicks on the button. So we go and we refresh the application. Again, everything looks exactly the same, except for now, when you look down at my md5.cache.html, it's gone down to 12.5K, which is fantastic. In fact, it's even better than when we first did it, because when we first ran the application, it was at 19K. So not only have I code split out all of the images, I've code split out the code that actually loads the images, and so my startup time is even faster. And then when we go over here to do the selecting of the icon, boom, we get them right away. So now you can see that I've fetched, so there's the fetch of the data bundle, right? It's 167K. And I've deferred that to when I clicked on it, but I've still bundled it so that I minimize my HTTP request, and I end up only waiting, again, 358 milliseconds here, and my receive time is 130 milliseconds. Again, very fast times, but when you're I'm on Ethernet. When you're on a degraded connection, say edge, it matters. When you have more than 16 images, it matters, right? When you have an application, like some of our internal applications, some of your applications as well, where you're up to, like, let's say a meg or 2 megs or 3 megs for your initial fragment, that's going to result in a very, very poor user experience on a mobile device. So what you can do is you can cut that out. I skipped over a slide. So this one slide to show you how easy it is to actually cut out that code. So all you have to do is, in this case, in my application, I had a show images dialog button. And all I had to do was guard that with a gwt.run async and give it a callback. And then the compiler knows that it can see all these split points, split them out, and you get separate JavaScript that it can go off and fetch later on. And it's all magically happening under the hood. You don't have to think about it. So if we look at it, it's pretty staggering, though, the difference in timing. So when you have this is the amount of time it's spent waiting. If you have a non-bundled application, you end up spending 1.4 seconds or 1,400 milliseconds waiting for the request to actually initiate, go, and then you start getting data. When you bundle it, you drop that down to 594 milliseconds, but you're incurring all of that on the startup. So the blue is startup, and the green is actually when you click the button. So you incur all of that latency on startup. But when you bundle and code split, right, you get the best of both worlds. You have minimal startup time, and then you have all of your bundling and all of your time spent when you click the button. So it makes a big difference. Then finally, I'd mentioned, so now that we've gone through and we've made it optimized, and we've said, okay, this is how we can bundle the code, this is how we can defer it, what we've done is we've said, okay, there's a set amount of JavaScript code that I have to use, and I'm going to move it around to when I actually need it. But let's see how we can basically minimize the amount of overall JavaScript that my application uses in the first place. And this is nothing that you have to do. This just happens for you magically when you use GWT. But this is the task application that I've been showing you. And what I've done is I've run it through the compiler using prettyprint. And so it's basically what it would look like if you did handwritten JavaScript. And you end up with a code size of roughly about, your initial fragment is about 1.1 megs. When you turn on the typical optimizations that the GWT compiler gives you, you're then hovering around 400 and change in terms of overall output size. So it's a pretty significant difference. You've cut it by more than 50%. And so again, the less JavaScript that you have, the less parse time, the less drain on the battery, the better user experience. So now we've talked about how to build great UIs for any form factor. We've talked about how to optimize the user experience. We've talked about how to make it snappier and actually make it run like an installable mobile application. Let's talk about how you can work without a connection. Because again, like I said, these devices are meant to be used on the go. They're meant to be used anywhere I want to. And in fact, the fact that it's easy to pull out of my pocket and use means that I'm more apt to use it than, say, my laptop. So the problems that were faced there are that you want to run wherever, whenever, right? You want to basically launch your application and have it bring up some user interface for you to use. For that, we can use application cache to load resources locally. Then once you have your application loaded, you want to be able to use it, right? You need to interact with data. You need to be able to access data wherever, whenever. And for that, we can use local storage to cache RPCs. So a little background on application cache. It's part of the HTML5 feature set. It works with files like HTML, CSS, and JavaScript. You can load those from disk. Works with iPhone and Android. And then it also works for Chrome, Safari, and Firefox. And to make this work with your GWT application, there's a few things you have to do. You end up declaring an app cache.nocache.manifest, right? This is just a file that you create. And then you go through and you list all of the permutations that you have, and you leave out all the RPC generated ones, and the fact that you create it, you call it no cache means that it'll always go fetch it. Then you go change your web XML file, and you actually add this manifest file, and you actually add the MIME type for it, and then you go through and you update your HTML file to include this manifest file, yada, 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 yada. Or you can just go check out the 2.4 SDK, where we started to make changes. Now it's in beta mode, and we're having to split it out. It's a little experimental, but the idea is that we know all of the files that are part of your application. Well, let's be honest. We know almost all of them. So we know all the permutations. We know all the JavaScript files. We know the CSS files that you're using. If you're doing resource bundling like I just mentioned, we know all of those files as well. And so we have this process when you go through and you compile and you have all these artifacts. At the end, we say, OK, pull it all together, right? We call that linking, very much like a normal compiler does, part of the normal compiler process. So what you can do is say, OK, well, typically when I link, I just spit out an HTML file, right? I spit out the special nocache.js, and then I have my permutations. But what you can do is you can specify a new app cache linker. And in this case, you would say, OK, Mr. GWT compiler, when you go and run, and when you're ready to link, don't use your standard linker. Use the one I'm suggesting here. And it's an app cache linker. And here's the path to it. And it knows how to handle everything for you. And then you can say, OK, by the way, now that I've defined this, use it in my application. And this code goes into your cloudtask.gwt.xml, basically your GWT application configuration file that I mentioned before. And then the reason that it's specific to your app right now, we're working through this, is that it knows that, OK, these are the set of files that I compiled. Do you have anything else that you want to add to the caching? If so, just let me know. And then you take care of it from there. So it ends up being about 4 lines of code instead of all of that stuff that I mentioned in the previous slide. So at that point in time, you can load your application from disk, even if you don't have a connection. Pops up. Not to mention, it's caching most of the files that you don't want to fetch anyway, so your application just becomes snappier to begin with. Because it's saying, all the browser does is says, OK, I have a manifest file. Go off and grab it. Has it changed? No, it hasn't changed. Great. I have all the resources that I need on disk. Load those up. Much faster than doing an RPC back and forth. OK, so now that I can load my application, I want to be able to read data from it and work with it. So how do I do that? So we can use local storage to make that happen. And again, much like app cache, it's part of the HTML5 feature set. If you don't know, it's a local database for reading and writing data. It's very simple, just a key value pair persistence. And again, works on iPhone, Android, and then Chrome, Safari, and Firefox. And this is already included. This shipped with the GWT 2.3 SDK. So the way that we would go about using this is in your application, anywhere you want to in your application, you simply need to get an instance of the storage class. So you say storage.getLocal storage if supported. And if you end up, and this is the if supported part, is a way of doing a runtime check. So if you're running on Chrome or Safari, you'll get back local storage. If you're running on IE 6, 7, or 8, you won't. And then you can fork your application from there and make the necessary changes. Like maybe you just choose not to do local storage. Like on IE6, you just happen to always fetch data over the wire, so that's it. They get a degraded performance. We want them to move to IE9 anyway, so that's OK. So let's say that we actually do get the local storage class back. We have an instance of it. We can start doing some really cool stuff with it. One way you might use it, and the way that we use it in this application is, well, OK, so your application somewhere in the code says, hey, I need tasks. So you have a method called getTasks. And what that would normally do in a fully connected world would say, just fire off an RPC, and when I get the task back, I'll update the application. And in this new kind of potentially offline world where we have local storage, what we'll do is in the method, we'll first say, OK, well, let me grab them from local storage. So let's say I get back a string. Great, that's a string that's representing my task list. Now I need to deserialize it, so now I have a list of tasks. That's great, these are the cached ones. And then I'll fire off an async request. This is where the async nature of the browser really helps out. You automatically fire off an async request, and you return, pass that list of tasks back to your application. It's none the wiser. Shows them, displays them. The RPC goes off. If it succeeds, that's fantastic. It comes back. And when it comes back, you say, OK, well, I've been waiting for that data. I'm glad you could get it for me. Let me go ahead and serialize it, get it in the string format. Let me persist it so that my cache is up to date for the next time I fetch it. And then you'll do whatever you need to do in your application, right? So you might pass an event on the event bus saying, like, hey, if you're listening for task updates, I've got one for you. Update the UI accordingly, and go on from there. And so now we've managed to go through and add the offline support we needed to the application, kind of bringing it all together. And what we'll do to prove it out is flip this off. And see, the nice thing to do is if the Wi-Fi completely went down in this demo, since it works offline, I was good to go. But let's force that to happen anyways. Back. Great. So we have application we've been using all along up. Let's go ahead and add a icon to the home screen to give us the full effect. So add shortcut to home. Over here, say bookmarks. Shortcut to home. All right. So note that we're connected. Let's go ahead and kill that. Now you can read my email. All right, so that's on. I have no connection. All right, airplane mode for both. Come back. Now there's a slight glitch that you'll have to deal with. This is a weird browser quirk we haven't gone around. Okay, so the first time I do it, it says, it realizes that it's offline and just throws up the default, I can't connect. But then what you see is that my application is connected. If I keep hitting refresh while I'm in airplane mode, I get it. I can actually see my task list, right? I get back support. Get the same thing over here. I can go through and I can see. Click. Back support. All right, and now, say I go away and leave my application. And then I'm driving through the subway. I'm in the middle of Kansas again, or I'm on the plane. I can just click on my icon. I've got my application here. I can select it. I can see all my data. I can go check out the Blue Bottle Coffee Shop because I hear they have great espresso. Same thing works on my phone. All my data is here. I can click on it and I can see it. So fully functioning mobile web app now. I'm not connected to the cloud at all. I have everything in my browser and it's actually operating like a real, true, installable application. Oh, thanks. So we've gone through a lot. We've gone through saying, okay, we have identified that we're web developers. We know we want to do mobile. It's the new hotness. We'd love to reuse our code. We know there's friction. We've gone through what those problems are. And we've identified that what you want to do is it's tough. You have to make UIs that work on every device. So you need tools and frameworks to make that easy to do. And that's what GWT provides, UI Binder and GWT Designer. You need to optimize for the user experience, right? You need to be able to pick that UI very easily, and you need to have it happen without you having to write, thousands of lines of code. You can do that with deferred properties and actually using built-in GWT features. And then finally, you need to optimize for the user experience, right? You need to make it as small as possible. So we've shown how we can bundle resources, how we can move them around your application to when you absolutely need them, and then we can ultimately, using the compiler, right, to do obfuscation, dead code analysis, method folding. You can actually reduce the overall size of your JavaScript by sometimes 50%, right? And then finally, we need APIs, good, easy-to-use APIs for working offline. We've demonstrated that using app cache, GWT linkers, and local storage support. So with these all in hand, I hope that you can actually now go back and look at your web app code and say, this is great. I've got 30,000 lines of code, and there's a good chance that I can go reuse 20,000 of them or 25,000 or however it may be, and easily get yourself a mobile web app that actually runs and can work offline and can work and have a great user experience. So thanks. And so all of the code that I mentioned is available now on our main code site. So you can just go download the 2.4 beta version of our SDK, and you'll see this application as well as the linker. And then other sessions that you might want to check out. So the page speed guys that helped me out with the graphs for what it looks like on a mobile device, they gave a talk yesterday, so be sure to go back and check out the YouTube link that we'll post on our main site. And then there's some great sessions that are happening today. So you have mobile web development from 0 to hero that's given by some of the Chrome guys. That's at 12:30 today. And then a fantastic, and I actually saw this rehearsed, a fantastic debate between the Chrome and the Android guys called HTML5 versus Android, apps or mobile web app development. There's actually a fight at the end. No, I'm just kidding. So that's it. Thanks for joining. And I've got now around 10 minutes to take Q&A.
It's working? Yeah.
Yep.
What about hardware acceleration? Hardware acceleration with GWT, and does GWT work with Canvas, HTML5 Canvas?
Yes, so GWT does work with HTML5 Canvas. It was one of the first APIs that we started supporting. So the list is Canvas, audio and video, local storage, and now the beginnings of app cache. And then the first part of your question was, does it work with hardware acceleration? Like, so are you talking about, do we have APIs for WebGL?
Yes, that's right.
Not yet. There's some game development going on and some talks today. So I would suggest like the kick-ass game programming with GWT later on today that you should go check out, and they're starting to talk about that.
Okay, just one last. How do I write JavaScript code on the GWT? For example, jQuery and those.
Well, if you're interested in jQuery, I would suggest you look at GWT query. It's kind of it's the parallel effort in the GWT world. And then if you just want to bump down and have handwritten JavaScript, suggest you go back and look at our main code site, or just use our search engine for looking up JSNI. So that's JavaScript Native Interface, and it'll show you how to jump from Java into native JavaScript.
Okay, thanks.
Yep.
Yeah. I have a question on your scrolling. Could you talk a little bit about how you can handle scrolling easily and handling touch events? We have a system that we built using GWT, and when we tried to use it on an iPad, it kind of was pretty difficult to implement that. We had to detect the touch events, and the scrolling was pretty bad. So is there any way, like, can we just say overflow scroll and then magically have it scroll with a single finger?
Were you using so there's a new panel called Touch Panel that implements that. Were you using the Touch Panel to do that? I mean, was it recently?
No, we did not use the Touch Panel. No.
Okay, so so what I was showing you here was based on a panel called Touch Panel. That's part of the 2.4 beta SDK. And while there still is a tad bit, I'll be honest with you, there's still a tad bit of flickering on the tablet. On the mobile device, it's very, very clean. So I'd suggest trying it out on an iPad, because I think that you'll see some better performance.
Okay, thanks.
Yep.
I've got a couple questions, but I guess first, is there just a good way to test the GWT code in a mobile browser? Because obviously you can't do development mode in there, and so the constant recompile is sometimes annoying. And then my other question is, I've tried taking some of the MVP design projects that we have, then they use Gin a lot, and the problem is sometimes the deferred binding, or the configuration that you would put in your module XML, it's hard to say if the form factor is tablet, then do a generator for this Gin thing, generate the tablet Ginjector, or the desktop Ginjector, or the mobile Ginjector. I mean, so it seems like there's a couple of, and Gin actually, I recall, has you can extend the configuration and introduce modules through the module XML as well, but it also doesn't always like that of saying, if this is the thing, then extend this and add this special module, desktop module or mobile module. So
is your general question, like, how do you use deferred bindings with Gin? Easily?
Yeah, sure.
Yeah. So I'm not the expert on Gin. I think there's one in the audience that I can defer to a little bit later, but why don't you catch us afterwards, and if not, we can exchange some emails to get an answer on if it's possible or if it actually is a very hairy route to go down.
Okay.
Yep, thanks.
Hi. I haven't used app cache yet, so this isn't really from personal experience, but from what I've read, there have been a lot of refresh issues that browsers aren't actually looking for new manifests and aren't going to download new resources Have you noticed that? Does GWT do anything to address that?
You know, I'll speak from, these are some hot bits that I'm testing out. So we've only really tried it out on Android tablets and Android phones. So far, we haven't had any problems. And I mean, so optimistically, I think that it's going to work perfectly fine on iPhones and iPads because they're both built from the WebKit base. And where they deviate, they don't deviate at the part of the code that actually goes and fetches the app cache manifest. So, so to answer your question, we haven't seen any problems on Android devices, and I don't believe we're going to find any problems on iPhone or iPad. But I do know that you know, there's inevitably a very strong push for HTML5 amongst those two browsers, and including Firefox. So any issues that we see, I expect to be resolved.
Okay, good enough. Thanks.
Yeah.
Hi. I assume in the offline mode, your application was read-only, like you cannot add tasks.
Right.
So I was thinking if there's any support in the works or any ideas about you know, syncing any modifications to the data.
So we've talked extensively about this, and in fact, we just talked about it yesterday. It would be a great engineering problem to go solve. We have various ways that we could do it, but myself and Ray, who's sitting right here, we've basically landed on that right now, at least. It's best to leave that up to the application developer, although it might be a little bit tricky. And because how you want to queue and how you want to be aggressive with fetching or not aggressive, you want to read through cache or write through cache, you know, whatever, that's kind of left up to the application developer. The one thing that I didn't show that would be interesting is the ability to take, like I omitted the serialization and deserialization code there. But if you're using things like request factory, it becomes very easy to just, all that code is already existing there. And so we could make it easier for you via APIs to say, here's my object graph. Can you just give me back a string, right? And we could give it back to you, and then you could store that away, right? And go from there. So the answer is that we're not going to tackle queuing of reads and writes for you yet, but we can provide APIs that make it easier. That's on the short-term roadmap.
Are there any examples out there
For
this kind of operation?
None that come to top of mind. I would say just do a quick search for it out there and see what you can find. Or, you know, there's 26,000 members on the GWT user group now. I would try maybe to ping them and see if there's anybody that's given it a shot.
Okay, thank you.
Yeah.
Hi, I think you partially answered this on the previous question, but with the offline support, so I've tried without GWT, just a plain HTML page, I've tried to do that with the iPhone browser, and I got error messages similar to the one that you just ran into, where it presented an error message, and then I think it continued to work after I dismissed the error. But that almost feels like a showstopper to me in terms of deploying something that I expect end users, you know, non-technical users to use. What else do you know about that error? It sounds like you haven't tried it on iPhone yet, I guess. I don't know. Do you know anything else about what's causing that or when it?
No, at this time I don't. And I mean, we'll continue to look into it because if I pop it up, well, if you want to see it, there's another part of the demo where you would show actually loading a page, and the page, like so for Google.com that does not have app cache in it, it literally would not load up at all. So yes, I think that it's I think it's a defect, and that's a browser one, I believe. But you know, we'll have to work through that and make it better and get rid of that pop-up that you saw. And if there's something that we can do in the way that we're constructing our app cache manifest file to get around it, yeah, we'll keep digging and find out, and then obviously we'd make that part of the linker that we're exposing.
Yep. Okay. Thanks.
Yeah, hi. Was wondering, you talked about resource bundling and form factor. Is there a plan to support different network latencies or network congestion issues so that I can have the one UI for low latency and another UI for high latency in my application?
Yeah, are you talking about low latency versus high latency?
Yeah, so that I can have low resolution images and sort of a linear application for hard cases.
Well, this might be a little bit crazy, but I don't think that you couldn't attack that from a deferred binding standpoint, at least not off the top of my head. What you'd end up doing is something a little more custom, where you could do timing of your RPCs, And if you happen to notice that it's taking over some threshold, you can kick your application into a different mode.
So I can hack it, but it's not supported built-in.
It's not that it's not, it's just not supported via deferred binding. Like deferred binding is something that we make like at the point of request, right? We're deciding, we decide which permutation to offer up. You could potentially do a custom one where you could do a check beforehand, and then you get some timing, and then if it's based on a threshold, you could pass that property along and do your own custom deferred binding. But at that point in time, I think that you're actually using the feature incorrectly, and it might actually be more code for you to write, rather than if you just picked up on the fact that, okay, my application just switched into a very, very high latency mode. So I'm going to have a way the way I forked for different devices, you could do that customly. And actually, the way that I forked for the orientation change, I didn't actually do that via deferred binding. I did that as a runtime check, right? And you could do the same thing, and you could say, okay, all those UI binder template files, forget those, because those are very graphic intensive. Let's go with my very, vanilla page over here. And then you have in the background a thread that keeps waking up. I call it a thread, but you just have some async code that's running that keeps checking for the timing of RPCs. And when you see that you're in a low latency area, do the switch again.
I see.
That would be my suggestion.
Okay, thank you.
Yep.
Hey. I got a question for the offline manifest. I was wondering if it was optimized for each browser. So if I'm in IE, do I download only the files that I need for IE, and if I am Firefox or on iPhone?
That's a good point. We'll have to go back and look at that. There is something that's a bit of a deficiency with app cache when you use it this way, and let me explain it, and hear me out on the entire portion of it. With app cache, right now, at least the way we have it and the way I demoed it, you're pulling down all the permutations, which is not optimal, right? But what you get in return, so it actually becomes like an installable experience. Imagine that if you're downloading an application from the Android marketplace, you're kind of fine with the fact that it takes 5 seconds or 10 seconds, or even if it takes a minute to download, right? Because it's downloading everything you need. So when you switch to the app cache mode, at least the way I demoed it, you're doing the exact same thing. You're saying, I want this application, and you get all the files associated with it. So right now, it's not totally optimal because you get all those other permutations. We can work on that. But then once you have them, right, you've installed the application, and now it just runs from disk. So it's much faster. So no, not right off the bat, but I know that we're hooking into the compilation system, and so there might be a way to actually split out and say, okay, compiler, you're asking me for the app cache manifest, and you're asking under these pretenses, which is Firefox or IE or Chrome.
Thank you.
Yep. All right. Cool. Thanks.